Hello viewers. The geometry I present to you here consists of a series of sub-diagrams. Each of these are connected to each other multiple times as the geometry folds back on itself. It's not just each sub-diagram that is connected, each component shape, almost every vertex or side, is multiply connected. The entire diagram, every shape you will see, was generated by a computer program using just 2 input coordinates. All shapes drawn are in themselves mathematically accurate to within the resolution of the image. If it is advertised as an equilateral or other defined triangle, it has been generated by the trigonometry to the exact pixel coordinates to fit. This creation of these is not what we would today consider as mathematics. There is nevertheless more than enough pattern for us to determine what his grand model was, and this is what is presented. We begin with Albert Dürer's method of deriving a pentagon from a hexagon, and the gouge on the N, which is present on all 4 extant Aspley copies of the Sonnets and the 2 John Wright copies that I've got, and I think on all of them. The 5 S's are coincident with an equilateral triangle of the same side length as the lower anonymous rule in the middle of the page. When calculated accurately, the right apex of the triangle is on the square dot in the right S, and the right side of the triangle slices straight through a dot on the first of 3 lowercase i's on the page in imprinted. The 3 central S's form a golden gnomon, a 36, 36, 108 degree triangle, cut from the equilateral triangle. Within that there is necessarily a pentagon, below which we can hang a hexagon, just as in Dürer's diagram. Dürer's 45 degree diagonal crosshairs between the outer vertices of the pentagon and the hexagon perfectly intersect the defective N in the centre of the page. The exact centre of this great triangle is on the right serif at the foot of the central N. This point forms the apex of a 51 degrees flat isosceles triangle, using the lower anonymous rule as a base. 51 degrees is the integer component of the slope of Khufu's pyramid in Giza. This value had been public domain information for 2 millennia by the time the sonnets were published. 51 has 2 prime factors, 3 and 17. 3 is the Trinity number, of course, and recurs throughout this cryptography, and it has a Latin gematria of C, which stands for Crucian. 17 is Oxford's Earl's number, and has a Latin gematria of R, which stands for Rosie. Now, these are just coincidences, of course, but the fact that Giza's pyramid has got an integer slope of 51 is exactly the kind of coincidence that they focus on. From the midpoint of this lower rule, there exists an inverted pentagram of the same side length as the triangle and the base of the pyramid. It is perfectly coincident with the left A. The inner sides of the left A form a perfect golden triangle. The right A is different, as we shall see later. Inside this pentagram is contained a pentagon. This pentagon almost perfectly bounds the hexagon we derived earlier along its lower side and its 2 outer vertices. The pentagram clips the T of sonnets at a point that 3 lines will eventually meet. The right foot of this inverted pentagram is on the R at a point which appears to have a raptor beak fashioned onto it. The falcon depicts Horus in Egyptian mythology. The upper diagram can thus be generated just from the lower rule, which will derive the centre and side length of the great equilateral triangle and the apex and side length of the great pentagram. There is a guide marker to the right of sonnets on its centre line. It is exactly 1/12 of the length of the baseline from its end. Its reflection across the common right vertex of the hexapentagon is almost exactly 1/4 from the opposite side. This illustrates that the perimeter of the hexagon is almost exactly that of the side length of the triangle, pentagon and pyramid base. There is a vertical from this node forming a sacred Tau cross. It is corroborated by a capital I, which eclipsed and borders in the same fashion as the geometry works throughout the page, and is terminated by the dot next to 1609. The centre line of never before imprinted is exactly half the width of the Great Pyramid and side length of the equilateral triangle below the strike-through of Sheikh-Spears. As such, we can form two squares coincident with the upper side and vertices of the great triangle that have their lower sides through the centre of never before. On the right quadrant, the two diagonals will clip the cerise of the T, in particular the wonky left bar at exactly the same point that the great pentagram clips it. The triple tau is one of the most prominent symbols in Freemasonry and forms the centre of the symbol for Royal Arch Freemasonry. It is comprised of a T above an H and represents the phrase Templum Hierosolymi, Solomon's Temple. To convert two squares into a triple tau, we can perform two operations. Firstly, cut off the top left and right corners with a 45-degree cut, then reflecting the remaining left and right half sections to make the triple tau. There is a perfectly formed mark on the centre of Shake-spears next to the R. It is at precisely 15 degrees from the vertical drawn from the bottom right corner of the right square. If we extrapolate that, which can be illustrated by extending the edges of a dodecagon as such, we can draw out our triple tau. The left end of the upper T of the triple tau terminates on the stem of the H. It is actually 1 millimetre inside the stem according to the predicted geometry. Within the inverted pentagram that bounds the hexagon of the vesica piscis, to the left we can derive a golden triangle as such, which is corroborated by the A. Our triple tau cuts this A along its bar, intersecting both nodes of the A. The golden triangle is almost perfectly coincident with the right node of the hexagon, and their bases are almost horizontally coincident. Hiram Aviv was given a golden hammer, symbolised by the temple T of the triple tau, and a golden triangle, symbolised by the A. I will go on to describe a star chart which will identify the right stem of the H and the stem of the K as the two pillars of the Temple of Solomon. The central node of the triple tau, between the O and R of before, will be used subsequently to derive several further elements. At the bottom of the page there is a circle first discussed by Alan Green in 2016. It consists of three triangles with specific trigonometric values for their angles. They reflect this quote from Kepler, published 3 years later. Kepler is discussing Pythagoras and the golden ratio. These two fundamental principles of Euclidean geometry are illustrated in this diagram, along with pi. The values of the golden ratio, known as phi, and pi were known to effectively over 4 digits, more than could be measured on this page in such a manner for at least half a millennia by 1609. These two numbers and the principle of Pythagoras' theorem constituted most of maths in the late 16th century. The circle is defined by its diameter between the huge stop after the G and the imprinted dot. I've repeatedly said the diagonal when I meant the diameter of the circle in the following audio, I'm afraid. The circle derives both of the horizontal anonymous rules, including therefore the base of the pyramid we have just discussed. It does this with 3 right-angled triangles formed from the diameter of the circle, the hypotenuse of each being the defining diameter of the circle. The G is the beginning and end of the normal logical description of the diagram. Its spot is huge and has a slight side flattened off, which will be shown to be at approximately 21 degrees. The dot next to imprinted has a triangular upper. If we assume it is an integer degree triangle, it appears to have a 51-degree slope. The 3 triangles have angles of inverse tangent of pi, such that its middle side is the length of the circumference of a circle of diameter equal to the short side. Then the inverse tangent of 3 over 4, or a 3-4-5 triangle. And finally, the last triangle has a short side which forms a golden ratio with the short side of the 3-4-5 triangle. It has an angle at the imprinted dot of inverse sine of 3 over 5 phi. The right angle of the pi triangle is approximately at the right end of the upper anonymous rule. The right angle of the 3-4-5 triangle is close to the dot after Aspley. This dot is at the same angle as the imprinted dot and is truncated. Extrapolating the apex of the pyramid brings it close to the predicted location of the 3-4-5 right-angled triangle. But we are still 1 millimetre to the left. This anomaly is consistent throughout the setting of Aspley. Everything is 1 millimetre to the left of where the model predicts it to be. I believe this is due to triangulation with elements other than the circle in the upper part of the page. The corner of the third phi triangle is at the 9 dot, the dot next to 1609. This dot has a hexagon cut onto its right side, which is sympathetic with several subsequent components. There is again a correction required of less than half a full stop, which I will discuss later. The page has been set using triangulation with points further up the page. It has not been set using compasses at the centre of the circle we are describing. The line from the corner of the phi triangle to the imprinted dot runs perfectly along the back of the second T of TT. We now need to draw 5 construction lines that define several intermediate points to describe the endpoints of our 2 anonymous horizontal rules. Firstly, there is a horizontal line from the centre of the spot next to the G. This perfectly cuts the centre of the 2 dots next to the 2 T's, and we will terminate it on the circle. There is then a line from the corner of the pi triangle at the top to the corner of the phi triangle at the bottom. It cuts the horizontal line we have just drawn at the dot after the second T. This dot has a golden gnomon, a 36-36-108 degree triangle cut onto it, and its apex is pointing at 30 degrees to the vertical. It is pointing at the kink in the A of Aspley. We now need to calculate the intersection of 2 lines to determine the left side of our lower anonymous rule. The first is a tangent to the circle from the spot next to the G, hence a line perpendicular to the diameter from G to imprinted. The second is a line drawn from the predicted corner of the 3-4-5 triangle through the point we have just derived for the golden gnomon-shaped dot to the second T. Where these 2 lines intersect is the left side of the lower rule. Where a horizontal from this point intersects the right side of the circle gives the right end of the lower anonymous rule. These 2 points define the bottom vertices of the Great Pyramid and hence the rest of the diagram. In principle, the entire model can be drawn with just 2 input points of the G and imprinted dots. There is now a 5th line, a chord which is parallel to the tangent at G and is drawn from the corner of the phi triangle, the 9 dot. The line cuts a horizontal drawn from the right side of the upper rule as described by the pi triangle. This construction line runs through a strange dot placed above and slightly to the left of the A of London. It has been very precisely placed there and is intersected by a total of 5 other lines. There are numerous further restrictions on the geometry beyond accurately predicting the anonymous rules and hence the basis of the upper diagram. The circle should be such that a golden gnomon, a 36-36-108 degree triangle, formed with its long side as the lower anonymous rule, should have its apex coincident with the circle. The perfectly round eye of the 6 of 1609 is exactly at this point. Furthermore, the dot of the second eye of William has a line cut through a golden rectangle. The geometry predicts this line with eerie precision. Within this golden gnomon exists a golden triangle, corroborated by the modified y and the slope of the w of William and the angle of the first t, all being at 18 degrees from the vertical and coincident with the 6. The right outside of the W is at 40 degrees from the apex of the gnomon. There is then the tau cross of the vesica piscis diagram above. It is coincident with the 9 dot. There are at least 3 further conditions connecting the upper to the lower diagrams. There are now 3 instances of each of the 3 triangles, equilateral, golden and right-angled isosceles. We already have a great equilateral triangle and also a great golden triangle from the great pentagram. The large right-angled isosceles triangle has its base as the upper anonymous rule we defined with Kepler's circle. It is slightly shorter on either side to the lower rule, that is the base of the Great Pyramid, and it is shorter on the right than the left. A 45-degree line from the right side will cut the great equilateral triangle at exactly the same point it intersects the tiny dot on the eye of imprinted. If we zoom into that dot, we can see it appears to have the bust of an ape-man carved onto it. This 45-degree line continues and it intersects the strike through of Sonnets, which is the interface between the pentagon and the hexagon, exactly at its midpoint, the midpoint of the entire diagram. The line then continues to the stem of the N, where it is intersected by the opposite 45-degree line from the left side of the upper rule. This apex is also coincident with the midline between Neu before and Shakes, which is 2 millimeters above the centre line of Sonnets. The second right-angled isosceles is defined as having its apex at the midpoint of the lower anonymous rule, the base of the Great Pyramid. Where a 45-degree line from there hits the construction line from the 9 dot to the left side of the upper rule, we define as the left vertex of this triangle. As you can see, it is exactly on this strange angstrom dot of that A. The reflection of this left vertex lands on the tiny dot fashioned onto the corner of the last N of at London. The diagonal of that N is at approximately 45 degrees. The second equilateral triangle has one side and its vertex defined as where a 30-degree line from the vertical drawn from the centre of the triple tau intersects the horizontal from G drawn to the left. This occurs at the base of the B of bi, where the bottom serif is rounded off and the top one is a large block square. The right node of this triangle is the dot after the first of the two T's. We define this as where a line drawn from the 9 dot to the centre of the diagonal cuts the horizontal. It has a hexagon fashioned onto its lower side. This point and the extension of that line have great further significance. It is one of the 3 stops on that line which are each used multiple times by the geometry. For now, it is just the right vertex of the second equilateral triangle. The apex, formed from a 30-degree line back from the vertical, is almost perfectly above the dot above the A, corroborating this element. We can reflect the line from bi through the triple tau to the R. It will run from the A of Shakes running symmetrically across its right leg and down to the R of R at the bottom. The original line runs from a triangle with A inside it up to the R of R. So we've got sort of 4 A's, 4 R's. I haven't decided what to call this object. The second golden triangle has its base defined as being horizontal and coincident with the apex of the Great Pyramid. Its right vertex is at the intersection of this horizontal and the extension of the golden gnomon of the Vesica Piscis. The 30-degree line from the central node of the triple tau extends upwards and is terminated at the height of the pentagram, which is also coincident with that R. The reflection of that point across the strike-through of Shakes defines the apex of the second golden triangle. There is a square dot at this point, which I believe signifies Venus. The derived left vertex of this triangle is the chocolate drip from the T of Sonnets. The line of the great triangle cuts through the S and this triangle at exactly the chocolate drip from the S, and the right vertex is suspiciously close to the comet shape full stop. If we extend the left side of this triangle down, it will pass through both the O's at the bottom. The upper one is exactly below the O of before. The one of 4, which is also cut by the golden triangle that we found from the golden gnomon at the bottom, forms a tiny golden triangle inside it. Now there are literally hundreds of golden triangles I could derive using the horizontal from any thus far derived node and the pentangular lines we already have, but none of them are going to turn up perfectly inside an O, which will turn out shortly to have enormous significance. The third equilateral triangle is defined as having its left vertex coincident with the 9 dot. This dot has a hexagon fashioned onto its right side. Its right side is defined as being coincident with the golden gnomon at stop after the second T. Doing so will produce a vertex which is almost perfectly coincident with the vertex of the second right-angled isosceles above at London. Its right side cuts the swoop of the A at a point with a kink in it. This reveals a 4. There will be 3 more of these. A 45-degree line from the left vertex of the Great Golden Triangle will run perfectly through the middle end of London and intersect the horizontal from the 9 dot at almost exactly the point of the right vertex of the smaller equilateral triangle. This point is the apex of an inverted right-angled isosceles. A 45-degree line from this point, terminated at a horizontal through the corner of the 3-4-5 triangle, will almost perfectly coincide with that right angle itself. The horizontal passes through a gap in the flimsy S of Aspley, and its left vertex is on the blobby end of the swoop. We now have 3 equilateral, 3 golden, and 3 right-angled isosceles triangles, all beautifully interconnected. There is now a star chart consisting of 6 lines, each drawn at exact integer degrees. Decimal notation hadn't been devised at this time. Rounding a number by discarding any fractions, in this case the minutes and seconds, was natural. The first line is from the great spot next to the G and signifies SN 1604, Kepler's star. It was, and still is, the most significant extrasolar event ever witnessed by the naked eye. It occurred a few months after De Vere's death, which was in the summer of that year. Any reference to it is conspicuously absent from the works. The spot has a side flattened off. We can see that it appears to be at 21 degrees, assuming it were signifying an integer angle. The G itself is sloped at approximately 21 degrees. An exact 21-degree line from the vertical drawn from the dead centre of the spot next to the G will drill straight through the centre of the claw on the left leg of the second A of Shakespeare. The line will run along the outside of the leg of the A and is terminated on the strike-through at a point just outside the A. A vertical line from this point will now arrow straight through both the point that the pentagram and diagonals of the right quadrant clip the left of the T of Sonnets and the monkey's head on the dot of the I have imprinted. It will then run straight through the gap on the flimsy S of Aspley. From the vertex of the great triangle, if we extend the left side of the triangle down, the line will pass through the centre of the golden gnomon-shaped stop next to the second T, and through the kink on the Aspley swoop, intersecting the vertical line from the A at the top at a point just a millimetre below Kepler's circle. This great 30-60-90 triangle I have called Kepler's triangle. There are 2 other 30-60-90s above it, which have their 60-degree vertices on the mouth of Athena. They are derived directly from the great equilateral triangle. We can easily derive dozens of 30-60-90s from the existing other equilaterals. These 2 tessellate nicely, and I think they are to be interpreted as a trinity, with the larger one below it. The right angle of this triangle cuts the left leg of the A in the same fashion as the Aspley A is cut, signifying a 4. The next 2 lines are both drawn from the dot next to the first of the 2 T's, currently the right apex of the medium equilateral triangle. They signify SN 1572, Tycho's star, and C 1577, the great comet of 1577. At 63 degrees to the horizontal and to the left is a line signifying SN 1572. The actual declination of Tycho's star is just over 64 degrees. Bra himself measured it at just under. Taking just the degree component leaves 63 degrees dead. There is a square white dot on the bottom of the left S, centred vertically on the letter and within it. Our flat 63-degree line runs well within 1 millimetre of it. In the other direction, an exactly 20-degree line from the vertical will pass straight through the comet-shaped dot after Sonnets. I have terminated this line, as I have Brahe's star line, on the vertical through the S. It arrives within 1 millimetre of the square white dot cut into the rightmost S and is centred both horizontally and vertically within the letter. In Brahe's own account of the comet, he states that it appeared in the constellation of Capricorn. The right ascension of Capricorn is 20 hours and then some minutes and seconds. I have assumed that we are, in this instance, to read the hours as degrees. The right star is Capricorn. The comet dot after Sonnets is now the confluence of the right vertex of the middle golden triangle, the extension of the upper golden gnomon, and the 20-degree great comet line. The 20-degree comet line runs to a point 8 pixels, about 1 millimetre, above the square dot on the right S, A direct line between the dot after the first T and the star dot on the S precisely intersects the comet stop, which has obviously been aligned to it and not exactly to the geometry. There are now 3 further stars drawn in connection with the square within the Vesica-Piscis diagram at the top. This square runs up the left side of the stem of that N and passes directly through the bauble that lies on top of it. An exactly 23-degree line from the apex of the middle golden triangle and terminated on the square will perfectly locate the centre of the bauble. 23 degrees was the declination of Venus as an evening star in 1609. Venus represented Horus in Egyptian mythology. In the opposite direction, drawn from the intersection of the hexagon and the triple tau as shown, there is a 49-degree line which arrows perfectly through the middle of the first N. The line continues to arrive at the intersection of the triple tau and the great golden triangle on the left node of the A. This marks the third 4 indicated from the 3 major capital A's. There is a hidden fourth. The line continues to point at a small square dot, perfectly positioned to fit with the behaviour of the 4 previous marks denoting stars, and it is at the top of the right stem of the H. In the Bayer catalogue, published just a few years earlier in 1603, there is only one navigable star at 49 degrees. It is Alcide, the leader of the 3 mourning maidens of the beard. The last of the ends already has a line through it. It's the 45-degree diagonal crosshairs of the Vesica-Piscis. The upper edge of it is at precisely 48 degrees. If we take the origin of the Vesica-Piscis crosshairs on the right vertex of the hexagon and draw at 48 degrees, it will run perfectly along the side of the N and point exactly at a very tiny single pixel dot at the head of the stem of the K. This insignificant mark is nevertheless perfectly positioned and is the largest blemish on this element. There is no star at 48 degrees in Bayer, so we have to use the complement as we already have several times in the star chart. 42 degrees only has one star. It is Arcan, the principal star of the Phoenix, first included in Bayer. A young Elizabeth I is depicted as the Phoenix in Henry VIII. In Arcan, the Phoenix and Venus, we have a group of 3 feminine stars. We now return to the circle at the bottom. Ward discovered in 2016 that there is a Cairo formed from the reflection of the diagonal of the circle and the extension of the line from the 9 dot to the centre of the circle, which we use to determine the location of the first T dot. This line will run up the side of the P of Shakespeare. Within this, with the important T dot at its centre and using the horizontal through G at its bar, is an inverted Petrine cross. It forms one of 3 crosses. We have the tau cross of the Vesica-Piscis diagram, and I consider the central cross with Shakespeare as its bar and the centre line of the diagram as its stem as a 3rd cross. The 4 points of the Cairo point to a message. Note that the originating diagonal of diagram cuts through the A of at and cuts the serif of the T. At can be taken to represent Aleph and Tav, the first and last letters of the Hebrew alphabet, and what we say as Alpha and the Omega, the beginning and the end. It appears on most Cairo instances. Note also that the model has predicted the dot of the A as being slightly to the right. If we move this character that amount to the right to match, the diagonal no longer barges through the A, but will cut it exactly at its right node in a similar but reflected manner to the 3 major capital A's. This A is a hidden 4. At also represents 4T. The chi of the Cairo can be interpreted as a plus sign. This was devised by Robert Record. D himself popularised this symbol after Record's death in 1558. The 4 points of the chi point to, by G, and then by picking 2 characters at each point, D, E, V, E, R, E, by God and De Vere, the 4th T. Returning to the centre of the Petrine cross, the strange Taurine T, the letters before it, and the O that has our tiny golden triangle within it. The string D for T has the O as its centre, it contains the term 4T, the fourth T. The T can be interpreted as a bull and hence an ox. This makes D for ox, which is trivially reversed to read Oxford. Removing that, we can take the remaining L and combine trivially with R and make Earl, and hence, by G again, Earl Oxford, the fourth T. D has signed his diagram in triplicate with a further fourth signature for good measure. Waugh discovered the principal delta dot signature formed by the lower arms of the Cairo and the bar of the Petrine cross. The huge spot next to the G is at its left vertex, and this triangle can be considered to be a reverse delta dot, a signature D used. The medium equilateral triangle has the angstrom dot of the A at its left vertex, and the small equilateral triangle at the bottom has the semi-hexagonal 9 dot at its vertex. These form a triplicate delta dot. I believe there's actually a fourth inverted and hidden delta dot that is the smaller triangle through Aspley that has the swoop dot at its left vertex. This is a hidden fourth D. This is what I have labelled Kepler's triangle, formed from the intersection of a 21-degree line from the spot next to the G to the strike-through of Shake-Spears. This triangle has 4 remarkable points of coincidence. The spot next to the second T is the confluence of 3 yellow lines, the third being defined as being coincident with the intersection of the first 2, as is the green line from the minor equilateral triangle. These yellow lines run between clear points on the page, the endpoints of the rules and the 9 and Aspley dots. They were discovered by Alan Green 8 years ago. The red line is derived from the great equilateral triangle, originally noticed by Alexander Waugh at the start of this subsequent investigation. Note that it is close to the green line, but about 1 millimetre to the right. This anomaly occurs throughout Aspley. On the dot of the I have imprinted, the vertical of Kepler's triangle cuts the 45-degree line from the half-square right-angled triangle formed from the upper anonymous rule and with its apex on the stem of the central N, precisely on the monkey's head on the I have imprinted. Note that near its apex, this triangle also near perfectly intersects the central point of the vesica piscis. The green line is the great equilateral triangle. The line is at 60 degrees. 90, 45 and 60 degrees are the most regular of angles. The area inside the triangle formed by these 3 lines is less than 1/16th of a square millimetre. Further up on the T, the half square from the right quadrant hits the T on its left bar. The opposing diagonal cuts the right bar of this T. The great pentagram cuts this T almost perfectly at the same point. 18 and 36 degrees are pentangular angles. It's why we have 360 degrees in a circle. After the square and the equilateral triangle, the pentagon is the most regular of objects and a symbol of knowledge. Humankind understood the golden ratio before they could read. The area that these 3 lines bound is less than 1/32nd of a square millimetre. There is then the great golden triangle on the left A and the diagram of Solomon's Temple. The correct point on the A is already marked by the strike-through of Shakes and the golden triangle. It is corroborated by the Alkide star line at 49 degrees. Again, the area of the triangle of coincidence is under 1/16th of a square millimetre. I have discussed the angstrom dot. It has 5 lines through it. There is an 18-degree alignment with the capital E of Eld, which may reveal the location of the missing third pentagon. There are numerous finer details I could discuss. The golden triangle within the O of D4 is just one exquisite example. It is the confluence of 3 lines, 2 from the trinity of golden triangles, and then the base line through the 3 ornate full stops. There is actually a 4th line intersecting it, the original construction line from the 9 dot to the left upper rule that intersects the angstrom dot. It runs within 1/10 of a millimetre to the left vertex of this triangle. I hope I've been able to articulate the beauty of this design. It is my own failing, if at this point you are not overcome by how complex this model is and how on earth it could have been conceived. I will discuss later what is not on this diagram, why Giza's pyramid shouldn't and doesn't need to be sensationalised. It's a pretty famous building. How Dee could have done this when he was dead, how problematic it is that only the Folger instance has these finer markings, and other issues. Note that all instances, including all of the 9 John Wrights, contain curios such as the R-gap, M-bauble, taurine T, and supersized spot next to the G. They knew there was magic to be copied. They will have been told to copy it. They just hadn't been told what it was or how insanely complex it was, and had no hope of maintaining the model. I've tried to present the geometry exhaustively and as concisely as I could manage. What I should have done at the head of this is to instruct you to watch Alexander Waugh's videos, and in particular this one, Where is Shakespeare Buried? Waugh is referred to the Masonic concept of the fourth T, the symbology of 3 T's and the hidden fourth T. This is represented in a stunningly regular group of rabuses forming a super rabus in the centre of Alexander's solution. I did some work at the beginning of this investigation using the works of Shakespeare, Dickens, the KGB, Art, and the Chilcot report, which is several times bigger than the rest of it put together. It should be possible to demonstrate that even using a much larger test suite consisting of terabytes of English text and a vocabulary consisting of Johnson's dictionary, the 15,000 words of an ecclesiastical Latin dictionary, the dictionary of national biography, and every place name in England, that the chances of getting this level of density, even allowing for anagrams, is extremely low and is unlikely to exist anywhere in natural text. Those of you with a background in statistical mechanics may like to focus on what you're looking at. Everything is interdependent. We have an entropy paradox ultimately, as we will continue to overlay further rabuses. The text of the Sonnets dedication is extremely special. Using plain text to find it is futile. I have also been investigating the monument. There are 17 notches on the slope and 40 across the bottom of the upper section. There are actually 4 1740s. I'm getting 4 instances of 4T and other principal themes on the geometry and the dedication. Around the back of the monument, while all I can do with the data I have is guess, we appear to have an array of triangles to complement Alexander's discovery of the 30, 60, 90 through Chaucer, De Vere and Spencer. We knew Drayton is aligned to the centre of the tomb. Spencer and Chaucer appear to be both at 45 degrees to De Vere and aligned from De Vere to Drayton. The point beneath Johnson is the same distance as Drayton's is from De Vere. Johnson appears to be staring down at 30 degrees, thus making a 30, 60, 90 in the vertical plane. Gray appears to be at 30 degrees, and possibly Gray's eyes is at the right position. My hunch is Drayton is staring down at 18 degrees, and possibly Gray's eyes is at the right position, but he's not looking in that direction. Spencer's monument has odd text. It isn't crazy enough to support a grid. The letter frequencies are intriguing. There are 17 O's and 39 E's. I believe the missing E is in other, but we're just working this out. We've only really just started looking at this. In view of what we now know, it would be very surprising to me if anything put there in the 17th or 18th centuries did not exhibit some geometric and or lexical reference to De Vere and the tomb. The Sonnets contains a trilogy of quite unprecedented cryptograms, the last of which is what is surely a stupendous number puzzle in the verse itself. I have made an independent capture of the Sonnets text in order that I can validate Green's claims in huge triangular numbers. I do not doubt Green's claims, but especially in the circumstances I need to verify this. Moreover, if I can reconcile Green's text with my own, we can employ the IT framework I've constructed to help reveal the true scale of this puzzle. This framework merely consists of marked up text and a program to count this data into Sonnets and page cells in a pair of spreadsheets, and code to perform gematria and all manner of tests on subsequent sheets to display the results from derived columns in triangular and other formations. I have wrestled with whether to just ignore Green's outrageous mathematics. If it was just that, I would have just ignored it. I can refute in detail everything he has proposed on that page, which I have not in turn repeated. Unfortunately, the core of Green's claims end up in Giza, where he is claiming that Planck, C, E, and not least Brun are encoded into Giza. We have a 51-degree pyramid. You could be excused for thinking Green's work and mine just merge. They do not. Green has labelled himself Bard Code and the Shakespeare equation. This stuff is quite ridiculous and extremely damaging to Oxfordianism. I cannot and am not really qualified to delve into number theory and the Riemann hypothesis. I used to understand it a bit. What I'm quite certain of is that Alan Green or John Dee or whoever built Giza has not overturned the Riemann hypothesis, which is what Green is in effect claiming. It is on the cast list of thousands upon thousands of mechanical proofs. It might be a hypothesis, but we know it's true. We just can't prove it. It might not be provable. It just is. You can't have Brun in 1609. It's just physically impossible. You have to add up trillions of numbers just to get anywhere near it. Maths is not natural philosophy. If you don't like maths, allow me to make it just that little bit worse. They are never wrong, ever. We just don't have plate tectonics or multi-galaxy universes in maths. Once these guys and gals have nailed something, that's it. It's maths. It will never be refuted. The analogy of plate tectonics is comforting to Oxfordians. Alas, being right is nowhere near good enough, as you well know. Being just better isn't good enough. It didn't take either geology nor astronomy 4 centuries to work out who came top in their own subject. This work is beyond the interest of senior Oxfordian scholars, War himself being the spectacular exception to that rule. Moreover, when I attempted to discuss this material with the larger Oxfordian group, I was bounced. Alan Green is ridiculous. I provided an extensive response explaining that my post, if they'd even attempted to read it, was dismantling Green's bogus claims. I received no response. This approach will not take you forward, Oxfordia. Comparing yourselves to Shakespeare will not bring victory. If you're interested in this work, all I can do is to now beg you to interact with it in some manner. A like or a comment would be appreciated. We all have egos, and it is rare to get more than a handful of either, but it should increase exposure. That's all I'm really concerned about. It's my hobby. I appreciate that most of you would rather sell your daughter to ISIS than share something on social media in some form. Can I ask you to consider doing this just this once, not selling your daughter? This is about eyeballs. I need problem solvers. I've just demonstrated finding 1740 on the front of that monument that had been looked up by 2 very diligent people. Actually, absolutely zero criticism to Alexander, either Alexanders actually. But, that's what happens when people start looking at it. And this is why when more Oxfordians turn up and start looking to prove a valid theory, guess what happens?